HRE Wheels is known for making custom-forged aluminum wheels, but our FlowForm brand is a fast-growing, lower-cost segment of wheels for us. A FlowForm wheel is produced using a casting process called FlowForming, essentially producing a hybrid of a cast and forged wheel and improving performance by increasing strength and reducing weight. Pricing for FlowForm is about 1/4 the price of an average HRE forged wheel set, but is still considered a premium market cast wheel. Our FlowForm wheels are available in 5 different styles, in 3 standard finishes, and over 30 optional finishes. The process for every wheel design starts off with an idea. A designer sketches possible design directions and themes which are narrowed down by our team, until a final direction is chosen. The designs are then 3D modeled and refined on the computer. The 3D modeler adjusts the design further depending on the engineering requirements of the target vehicle and applications, balancing style and strength. We check the strength of the design using FEA, finite element analysis, which simulates the stresses in a real-world environment. FEA will highlight areas that need to be adjusted by adding or removing material or changing the wheel design further to meet the criteria we input. The wheels will later be physically tested to confirm these simulations. Once the design is completed, the factory issues a final technical drawing to confirm and sign off. Sometimes small details or dimensions are edited at this stage based on the factory's feedback. Once confirmed, the factory creates the mold tooling before moving on to the production process. The raw material for our FlowForm wheels starts as a raw bar of A356.2 aluminum alloy, known for its strength and favorable casting properties. The bar stock is melted in a furnace at about 1400 degrees Fahrenheit, where it will be filtered, degassed, and inspected. Depending on the size of the mold, 50 to 100 pounds of molten aluminum, now at over 1300 degrees Fahrenheit, is poured into the steel mold. The face of the wheel is located at the bottom of the mold, helping to create stronger spokes than a traditional cast wheel. Once solid, the casting is removed from the mold and quenched in 120 degree Fahrenheit water. Here, mold flashings are removed, and general measurements are taken confirming correct wheel sizing. At this stage, you can see some of the spoke characteristics of a cast design. One of the distinguishing characteristics of a flow-formed casting is the short rim barrel skirt that hasn't yet been molded into the full rim width. This thick skirt material is later flow-formed, a process that squeezes and stretches aluminum, refining the crystalline structure of the metal to create a strong inner barrel that absorbs impact energy better than one that is fully casted. To prepare for flow forming, the castings are loaded onto a conveyor that takes them through a preheat oven. The mandrel is pre-sprayed with a release agent to ease the removal of the flow-formed wheel once complete. Each casting is placed on the preheated mandrel, which is shaped to the rim barrel profile. The rollers slowly squeeze the aluminum skirt into the final rim barrel shape along the mandrel's sides. It will take multiple passes of the rollers to move all the skirt material into its final rim barrel shape. The wheels are again quenched to ensure the mechanical properties are maintained and to minimize distortion. Next, the castings are taken to a heat treat stage. Heat treating is a process that further refines and aligns the aluminum structure, locking in the proper hardness levels by heating up the castings, then quickly quenching them. Now that the flow forming process is complete, The castings are put through the first of many tests. The wheels are X-rayed to ensure they are free of voids and cracks not visible to the naked eye that could lead to potential quality issues. At this stage, these visible ridges in the rim barrel are the result of the flow-forming process and the squeezing of aluminum over the mandrel, producing the final barrel's profile, cross-section, and width. Next, a lathing process removes excess casting material and creates the final rim profile geometry intended by our designers. Detail machining then creates the lug holes at the required PCD, or pitch circle diameter, hub bore, and valve stem hole. This is followed by a quality control step of checking the concentricity of the PCD and center bore. Now at the last stage before cleaning, the final surfaces have been machined, including the barrel, lug, and valve holes, center bore, and wheel face. Once the final geometry is achieved, balance and runout are checked. This will confirm the concentricity of the new wheels and that they meet balance requirements. The next test is a leak test, simulating the pressure on the wheel created when a tire is mounted. This ensures the wheel properly maintains the tire pressure needed to sustain a tire under load. When the wheels pass these QC steps, they proceed to the cleaning line where they are loaded onto a hanging line one by one. Once inside the cleaning chamber, they make their way through a cleaning process, removing all manufacturing, machining, and test debris. Our standard black powder coat, called tarmac, is applied on this painting line. Powder coat is made up of a fine plastic powder applied to the wheel with an electrostatic charge. Once fully coated, it is heated to melt and cure the powder until it hardens into a robust protective shell, stronger than liquid paint alone. Following the powder coat, a liquid clear coat is sprayed, creating the satin sheen on the final tarmac color. A waterfall and air pressure span the length of the entire spray booth to keep down dust and overspray. The wheels are spun to ensure a consistent amount of powder coat and clear coat is applied to every surface on the wheel equally. Next, one of our other standard finishes, called liquid metal, is created using a hand-sprayed fading technique. First, a base black is applied over the entire wheel, and then a liquid silver paint is sprayed over the face of the wheel, creating the dynamic depth of our liquid metal finish. Our FlowForm wheels are all designed to German TÜV standards and undergo strict physical testing to ensure they meet these standards. The first is the radial test. The wheel is fitted to a tire and tested to simulate long-distance driving under load. The wheels need to have high fatigue resistance and durability to resist cracking. The cornering test simulates a high-performance vehicle in a cornering situation pulling high lateral Gs. The impact test simulates potholes or other abrupt impacts the wheel may encounter. To meet the requirements, the wheel will deform after impact but will not lose air. This is so the vehicle can come to a stop safely without tire pressure loss. Once the tests are complete, a red dye penetrant and white top coat are applied to the wheel, making any cracks easily visible during this quality control check. Prior to shipping, the finished wheel goes through a number of final QC steps, including center cap test fit, size, offset, PCD, center bore, and one last runout test. A visual test to confirm color and finish quality are also performed on the front and back of each wheel. Only after the wheels have passed all tests do they then become a FlowForm wheel. It is then boxed and shipped to San Diego, where we receive them in our warehouse for another inspection. before they are shipped to your local dealer for tire mounting and vehicle installation. With a wide range of diameters, fitments, styles, and colors, our official FlowForm wheels are quickly becoming a favorite among car enthusiasts everywhere.